Hello everyone and welcome back to our channel Quaint. Today's topic of discussion is Lenz law, and you can find this topic in the subject of electromagnetism. According to my knowledge, many students don't like this law since it has no mathematical expression. Means many students ignore this law since it has no mathematical expression, but actually this is wrong. It has mathematical expression, it is used in mathematics. Okay, so if you study Faraday's law of electromagnetic induction, then you can see that the mathematical expression of that law is what? It is given by epsilon. You can see on the screen, epsilon is equal to minus d phi dt, where epsilon represents induced EMF or induced electromotive force. Phi represents magnetic flux, T represents time. Therefore, d phi dt together represents a rate of change of magnetic flux with respect to time. But there is a negative sign, and that negative sign comes from Lenz law. Lenz law states that the induced current, the direction of the induced current is always such that it opposes the change that caused it. Yes, according to Lenz law. What is the Lenz law? It states that the direction of the induced current is always such that it opposes the change that caused it. You know, whenever there is a relative motion between a magnet and a coil of wire, in that case induced current you can find, means current is induced in the coil of wire. So in that case, means whenever there is a change in the magnetic flux, current is induced. You can do such an experiment at your home also. Just take a copper tube, a long copper tube. Better you need to take a long copper tube, okay, and take a magnet, okay, and now drop the magnet and hold the copper tube vertically, and using your another hand take a magnet and drop through the top hole of the copper tube and see what happens. You can see that if you observe carefully, if you can note down the time, okay, so you can easily see that the magnet is not freely falling toward the ground. Okay, the motion of the magnet is being resisted by an invisible force. You can easily compare. Say for example, but for this experiment you have to take a sufficiently long tube. Otherwise at home you cannot check the difference. Okay, take a long tube, it's better. And take any object which is non-magnetic. Okay, take any object, say for example a stone, and do the experiment. Note down the time. Say for the stone, the time it takes to cover the distance of the means to cover the length of the pipe is 5 seconds. You have found 5 seconds. But whenever you take a magnet and do the same experiment, in that case you will get a time which is less than 5 seconds. And if the magnet is strong enough, means the magnetic field created by the magnet is very strong, in that case the time will be lesser than the previous one. What is the reason behind this? The reason is that whenever the magnet is falling through the copper tube or copper pipe, whenever the magnet is falling through that, in that case there is a change in the magnetic flux. Since it is in motion, there is a relative motion between the magnet and the copper tube. And due to this change in flux, due to this change in magnetic flux, current is induced in the walls of the copper tube. And that induced current is opposing the motion of the magnet. That's why, that means here on the magnet not only the force, gravity is acting on that. Gravity is acting in the downward direction, but a force is also acting simultaneously in the upward direction. That's why the net force acting on the magnet becomes somewhat less. Okay, net effective force acting on the magnet in the downward direction, it is reduced to somewhat, and that's why it takes longer as compared to the stone, which is non-magnetic in nature. That means we can see from this experiment, nature always fight back against any external influence that tries to change the electromagnetic balance. We can say this way also, nature always fight backs. Okay, nature always fights back against any external influence that tries to disturb the electromagnetic balance of the system. And you can see, in case of Faraday's law of electromagnetic induction, that negative sign is because of this law, Lenz law. And if you think that without using that negative sign, you can use Faraday's law of induction, then that is absolutely wrong. Okay, if you use Maxwell's 4 equations, where third equation is the Faraday's law of electromagnetic induction, and if you try to find the combined solution of all those 4 equations, and in that case if you do not use the negative sign, then you will get erroneous result. Negative sign is required. It is just not to enhancing the beauty of the equation. Mathematically it is required, the negative sign. And this is the importance of Lenz law. Okay, and if you talk about practical applications, so many things are there where you can find the practical applications of this thing, this Lenz law, such as braking system. If you observe carefully the braking system of trains or roller coaster, then same thing happens there. There is a moving conductor and magnetic field are also there. So whenever the moving conductor whenever the conductor moves through the magnetic field, in that case eddy currents are generated, and that eddy currents opposes the motion of the conductor, and that way the braking system works. In case of what? In case of trains and roller coasters, many where this braking system can be applied. Okay, again in case of induction oven or induction cooktops, you can find the same thing. In case of induction oven, there is no visible flame. Still the pan which you are using to cook your food, that is being heated up, no flame is visible. Still it's happening. That means here also Lenz law is in action. Okay. The heat is being generated because of the Lenz law. Again, in case of metal detectors, same thing. Say you are carrying a metal with you. Say, for example, you are carrying a knife with you, and people who are looking for this matter, okay, looking after this matter, they are using metal detector. So whenever the metal detector comes, means whenever you approach to the metal detector, in that case, and the metal detector actually that spreads the electromagnetic field. Okay. So whenever the object, means the knife, comes in close contact with that magnetic field, in that case what happens? Current is induced in your knife. Okay, and that current causes what? That current causes a magnetic field. That also generates a magnetic field. And that magnetic field is sensed by the detector. Whenever your knife creates a magnetic field due to the induced current, so that magnetic field is detected by the detector, metal detector. So that way metal detector works. So many things are there, so many examples are there. You can, again, in case of generators and transformers, same thing is there. Again, many students are there who say, means due to their misunderstanding, they used to say normally that Lenz law is going against the conservation of energy principle. No, Lenz law doesn't go against the conservation of energy principle. If you look carefully, if you observe carefully, then you can see that it is not going against conservation of energy principle. Conservation of energy principle is well preserved in case of Lenz law. No violation is there. But you have to analyze the problem carefully. Then only you can see that conservation of energy principle is not being violated whenever you are following Lenz law. Okay, that means what? That means Lenz law is very important. And one more thing we have found by using this law, that nature always tries to oppose these sudden changes in its electromagnetic balance. Anyway, so this was all about today's topic. If you found this topic to be interesting, then please like, share and subscribe to our channel. So see you in the next video. Till then, goodbye.